or as x approaches some value. Okay, so we'll talk a little bit more. I should say theoretical lines that represent what happens to the output as x approaches infinity or x approaches some value. So for example, as x went to infinity, the output came down towards 0. As x approached 0, the output approached infinity. So it's kind of, in this case, it's sort of the reverse. Okay, well, we have two types of asymptotes. This guy here is called a vertical asymptote because it's a vertical line. It goes up and down. And this is called a horizontal asymptote because it goes left and right. Sorry, this guy here is called a horizontal asymptote. Again, these are theoretical lines. These are kind of like boundaries for your function. And of course, they can get pretty complicated, but we're just trying to understand some of the basics. Okay, so a vertical asymptote, you noticed, occurred when the output was undefined. So we'll just say a vertical asymptote occurs when the output is undefined. Okay, so in this case, let's look back at our equation. So it's W equals 56,000 divided by 52H. So from a mathematical perspective, when will this problem be undefined? Well, we can't divide by 0. So anytime you have a divide by 0 situation, that's going to create an undefined output. Anytime you have the square root of a negative, that's going to have an undefined output. These are just a couple of settings, and there are definitely other ones. But so what we need to figure out in order to determine where the vertical asymptote is going to be is to figure out when is this 0. So when does this equal 0? Well, 52 times h will equal 0 when? Well, when h is 0, because the only way to get 52 times something to equal 0 is when h is equal to 0. So that would tell us that we're going to have a vertical asymptote that goes basically up and down, and it's right on top of the vertical axis. Now, horizontal asymptote gets a little bit more complicated, which we will talk about here in a second, but let's look at another example. Let's just say that we have a generic function just to get a little bit more comfortable with this. Now I'm going to make this look kind of complicated, but let's say you have 3x plus 6 over 2x minus 4. Okay, well, when's this going to be, what are going to be the vertical asymptotes? Well, we just defined it earlier. We said you're going to have a vertical asymptote whenever you have an undefined output. Well, the only way, again, to have an undefined output here, it doesn't really matter what happens up here. I could have 0, I could have 100, I could have negative 2,000. The only time I'll get a problem is if this equals 0. Well, when will 2x minus 4 equal 0? That's our question. Well, you can probably look at this and say, oh, well, wait a minute. If I put in a 2 for x, I'll get 2 times 2 is 4, minus 4 is 0. Alternatively, if you wanted to solve it, you could use a calculator, and you can solve it that way. But if you just want to do your old algebra, you could say 2x, add 4 to both sides, equals 0 plus 4, which is 4. And now divide by 2, and you would get 4 divided by 2 equals 2. So you get x equals 2 would be the asymptote. So that means that if we looked at the graph of this at 1, 2, we would have a vertical line going up and down that basically says, hey, that point's undefined, and as x approaches that point coming this direction, well, we don't really know. Do the outputs go down, or do the outputs go up, or do they go down? Well, let's take a look at this. So I have it entered here into my calculator, and now I'm just going to set my zoom. I'm going to go to a standard zoom window just to kind of be able to picture what this thing looks like. Wow, there it is. Kind of crazy graph. But you can notice that at x equals 2, it seems like the function almost like magnetically kind of flies away from actually intersecting through this imaginary line. If you can kind of see this imaginary line here, as x approaches 2 from this direction, then the outputs go up infinitely. But as x approaches 2 from the right, the outputs go down infinitely. So we correctly figured out that the vertical asymptote is at